Hey guys, thanks for tuning into CMTEQ channel in the C++ programming snippet. So in this tutorial, I'm going to demonstrate to you some of the key features of C++ programming using these three key electronics components, namely the resistor, inductor, and capacitor. Well, we know that C is an efficient portable language and it is very easy to learn and sometimes very difficult to use. Right, you can commit a lot of errors while using C programming. In the other hand, your C++ is very flexible, powerful, right? And it is object oriented. Okay, so that basically means it gives you more flexibility. The problem with C++, it is difficult to learn. But do not worry, we're going to demonstrate these key features of C++ using something that is more familiar to us. Components, electronics component. So if you find this tutorial useful by the end of this tutorial, please give it a thumbs up and subscribe to CMTEQ channel. That will be much appreciated. So we know that C++ is an object-oriented programming language. So that basically means you can create objects, and objects are entities that have data and some associated behaviors with them. So some of the features, they are listed here as you can see. They are classes, object, right? Encapsulations, abstractions, inheritance, and polymorphism, right? So some of these features, they're very advanced C++ features that you will not be using in a very simple C++ programming script. So without wasting any further time, let's go ahead and demonstrate how to use classes, objects, and encapsulation by making use of these three electronics components. So you've got your skeleton program here. So you basically need a problem, right? You need to solve a problem. So what is the problem? The problem is you need to write a simple C++ program that lists a component and its value, right? So the components are the one that we already show here, that are resistor, inductor, and capacitor. So we need to be able to say, okay, this is a resistor and it has a value of so and so. And the same with inductors and capacitor. Now this can be achieved by probably simply writing a simple printout statement that will print this is a resistor with a value of 10 ohm. But the point here is we want to demonstrate these features, classes and object and encapsulation, their usage in C++. So the first thing we're going to do is we're going to create a class of component. So basically we're going to call this class component. Okay. Right now, in this class, we're going to have two private members, okay? Two private members. So I'm going to go ahead and create those private members. So now these private members, you have to give them some data type, okay? So we're going to first create one private member that will be a string, okay? And this string is going to be basically the name. So that will be holding the name of the component. Okay, and another private member is going to be an integer that will basically going to be holding the value of the component. Now you may say, but wait a minute, how are we going to access this private member variable that we just created? Well, you are right. To actually access them, you have to make them public because they are private, they are hidden from the outside world. So to make them public, we're going to call this feature called encapsulation. So to implement encapsulation, we're going to basically create a public member function, two public member functions. So we're going to call the keyword public. Okay, and under this keyword public here, we basically going to create another function, component. And here we're going to define new variable that can be accessible from the outside world. So the first one is going to be cval, that stands for component value, and then string cname, that stands for component name. And inside our public member function here, we're going to call the this. Basically we'll be pointing out to the first variable, the private variable function that we created, okay? And that is going to be equal to cname And we're going to do exactly the same thing with the component value. Okay, val, and that is going to be equal to C val, right? So we've just achieved our encapsulation here. So now we're going to go ahead and create another public member function that is now going to allow us to access these variables that have now been made public through a different camouflage, basically a different name, but we will be accessing them. Okay, so we're going to create another function that I'm going to call info, for information. Okay, and in this function here, I'm basically going to print out what I want to print out when I call the name and the value of the component. So first we're gonna just say a cout, and we're going to say this is, and we're going to say this is a, right? And then we need to pass now the value of the component. Now remember, this is private, but now we are able to access them because of this encapsulation that we've made them public there. Okay, and then here we basically going to pass the unit, which is ohm. So let's bring the character map here and select, right? So we're just going to copy it, and then we're going to paste it right there. So that basically going to be ohm, and we're going to pass the name of the component. Then we end the line right there. Right, so now we've done creating an example of an encapsulation class here with private members that we've made public here by accessing them via the void info function. So now let's go ahead and implement this basically by using this class of component into our main function. So now to do that, this is where we're going to use these second features of C++. So basically we're going to create object. Okay, now to demonstrate the use of object here, I'm going to create an object of the class component, which I will need a keyword component so that I can create that object of that class. And then the name here is now going to be up to me, so I'm going to name it component1. Okay, and now here I need to pass the parameters that have now been made public to me, which are cval and cname. So here for the one component, I first need a value. Okay, so that's going to be, let's say 10, an integer, and the next one is going to be a string. So I have to go ahead and pass a string there. I'm going to say resistor. Now to display this resistor and its value, I'm going to call another function, which is a public member function of the component class, which is info. So to do that, my task becomes very easy here. So all I'm going to do is to basically just say component1 dot info. You can see the option is already been given to me, and that's it. That's it. So basically, as soon as I create an object, component1, which is an object of the component class, I've already got access to this function here. So when I say component1.info, it knows already that this is what must be printed. So let's go ahead and give this a try. There we go. This is a 10 ohm resistor. There is a space that we need to introduce somewhere here after the ohm, right? This is a 10 ohm resistor. Now let's say you want to add another component that you want to create. Maybe let's say you want to add a capacitor. Okay, you want to add a capacitor. So you're going to just say component2, right? And you just going to put a value here for your capacitor. So let's say you say 15, okay, and you change this to capacitor. Okay, then here to call it, you basically just repeat exactly the same thing, component2 dot info. Okay, now you can go ahead and test these as well. There we go. This is a 10 ohm resistor. This is a 15 ohm capacitor. Whoa. There is a problem here. There is no 15 ohm capacitor that exists. So that basically means we have to do something here in this info code here so that we can print the capacitor should be microfarad, right? Or picofarad or whatever the case is. So we have to do something here. So to modify this is actually quite very easy. We can just add an if statement here. Okay, so we can just add an if statement where we're going to say, okay, if name is equal to resistor. Okay, if name is equal to resistor, we basically going to print this one here, and then we say else if name is equal to capacitor, else if name is equal to capacitor, and this is what we're going to do if the name is equal to capacitor. So we basically going to say, and here we have to change to something like microfarad. So it should be able to detect the information that you provided, okay, and it's going to print exactly that. So let's just give this another try and see if indeed it's going to print what we suggested there. So let's see. There we go. This is a 10 ohm resistor. This is a 15 microfarad capacitor. So it's basically working. So this is basically how you can go on and add another component here. You already have access to this class here. So this is how you implement classes, right? An object and an encapsulation class, and then the object that you can access it. So thank you guys for watching. If you find this tutorial useful, please subscribe to CMTEQ channel and give this tutorial a thumbs up. Stay tuned for more upcoming tutorial where we're basically going to cover the use of abstraction, inheritance, and polymorphism in this very same script that we have here. Until next time, cheers.